tendency of a lot of people to just go out, clean the sensor, and just say, oh, I cleaned it, and just leave. But proper practice, proper science practice, proper metadata, documentation, you document when you do things. So we document when it was cleaned so that we just know. And you can often trace that back and see changes in the data, as I showed in that presentation.
What's holding that in there? Just a metal pin?
So this black thing is a stake that's driven into the stream bed. This is a 3-foot stake, and you can see it's that deep. So 2 feet of that stake are underground.
Wow.
And then this plastic PVC with this pin here fits on top, and then you slide that pin through. There's holes in the rebar and holes in the PVC, so that it stays in place. And if you take it off, you can put it back to the exact same depth. That's pretty key. There's plenty of ways to measure depth. There's other ways to measure depth other than this, but regardless, you have to be consistent with where you actually put that thing. If you take a bunch of depth measurements, take the sensor out, and then put it back in at a different depth, it's going to throw off all your data, right? So you have to keep that consistent placement of the depth sensor, otherwise you're going to have to sort of do a recalibration. And that's why this was designed as the way it was, so that with that pin, you always can put it back to the exact same level. Yeah.
Dave, do you turn off the mayfly before you clean?
I did not turn it off.
But should we?
Should you?
Okay.
No, I don't think it's necessary.
But does it hurt if
It's not going to hurt.
Okay.
Certainly it's not going to hurt, but there's not really any real reason to turn it off when cleaning.
Okay.
Now, this is a little bit, tangential to this topic for the workshop, but with regard to these stations, you absolutely have to turn the station off when you remove the SD card. Take out the SD card when it's turned off, put in a blank one, and then turn it back on. That's super important.
Okay.
That's, I think...
If I can interrupt real quick. Our sensor downstream needs to be cleaned. So when we take them down, we would love to actually clean it. So
Okay,
they can see
good.
this in more
And maybe
detail.
one of these folks can actually get in there and do it.
So just putting it out there.
And I suggest that we talk about cleaning the staff gauge. So for example, it gets mucked up, and now with the stream lowered, you would be able to see its
Yeah,
level.
the stream lowers, and it's pretty gunked on there too.
Now,
So I think
you can get it off with a nail often.
is it
Not that you
gunk or
should
has
do it,
been-
David,
Or is it just wearing?
I think it's just gone.
You think it's rusted?
Yeah, that's
It sort of wears off,
the
yeah.
second staff gauge we had to put in because it's the
So this
the
black
line-
stuff,
the-
stuff can be scraped off.
Yeah.
black stuff
Yeah,
goes
yeah.
off.
You
The
just need
clear
something a little-
lamination comes off.
Yeah, we've had. Oh yeah, you're right. We've had the actual like.
So,
But
measurement.
to read it, you need to get that black stuff.
so all this is relatively straightforward stuff to think about and to talk about. But when it comes to the actual logistics, like this type of thing, it's not just a snap of the fingers to come out and replace a staff gauge.
How do you replace it?
Well,
What?
you just come in and you try to keep it at the same position, and you want to, you have that offset. So
Right,
You want
you can
to
measure
put
it.
it in. You want it to that offset to be the same. So you want to know what that depth is, and then put this in accordingly, so you get the same offset. But the part that's hard is mounting this. Well, not necessarily hard, but takes time. Is mounting this to this, and primarily getting this into the stream bed so that it's stable. So if you've got rocks or whatever, it can be really hard to get in there. This is semi-permanent.
Right.
Permanent ones are a huge undertaking where they pour concrete and all this and that. We're not doing that. This just isn't at that level.
Yeah, but can't you just unscrew the roller part and replace the bottom roller?
Yeah, it just depends on what's happening with
Yeah,
you've
but-
had ones that have been completely
Yeah, they're in the back
destroyed.
of my truck right
The
now.
entire thing. just
So
destroyed.
you do use like a 5/8 or 3/4 solid, right? For
This
like
is 3/4 here.
that's 3/4, but it's hollow, right? I mean that's like
Yeah,
a
that's hollow.
conduit. You use those are solid, or were they not?
No, it's the same thing.
Same thing.
Yeah.
So my suggestion, just from putting in grounding rods for electrical, you could find the OD of a grounding rod, which is a solid piece of wire, or any solid, right? Any solid, and then it would fit inside of the ID of this pipe so that you would have a solid rod, and then you have a redundancy so
That's
that
an interesting idea.
yeah. I have a tool that I drive it with. You don't use a hammer. It basically you're just jackhammering it with a tool that's got a
So
cup.
maybe we can talk about
Yeah,
that
yeah.
like at another time, because that's
Yeah,
something
sorry,
we've
sorry.
No, it's great. I just
it's
mean
good,
like there's
yeah.
more to talk about with that, and because we've been sort of thinking about more resilient solutions.
What is this arrangement here?
This is a DO sensor.
So the DO sensor is not wired up to the data logger. It's
Okay.
battery powered, it's got its own memory card in it, so it's not transmitting the data to the portal. We have to manually come out and take the data
Where
from
do you
it.
retrieve the card from?
It's like,
Inside?
it's a cylinder that has a screw cap, and you unscrew it, and then the equipment is kind of in this
Encased.
waterproof case, and that's where everything is. We haven't collected any data from it yet, but these were deployed, in like March.
Fairly recently, right?
In March. So
All right.
this is a new addition for us.
So let's try to stay on relative target here. Has everyone gotten the header information completed? You wrote in the sensor cleaning, you got logger, you got your names on the sheets, last names on the sheets, on the field sheet and the discharge sheet.
Did you tell them about what time?
Yeah, it was 1:47.
Yeah.
This thing is uploading or collecting measurements at every 5-minute interval. So you look at your watch and you go, okay, it's 5:53. In 2 minutes, it's going to burp another bunch of data up. So I want to get in and clean it inside of that window so that I haven't stirred up sediment
so let's
around
go,
it. So,
get out your smartphones.
yeah.
Get out your smartphones. And let's go to the site. We're going to get to this here soon anyways.
Oh, I jumped. Sorry.
No. It's, I mean, that ties in exactly.
Oh,
Perfect time. Okay, so drwisensors.greenhosters.com.
Yes.
Okay.
Put the 3 of them saved in there. Oh, what's going on over there?
What are you looking at? So it was it's recording pretty well. It's oh no, it's 12:51. So it's just 3 minutes to one.
well,
So
there's
this
a
one's
delay.
late?
So go to SL155. Click on that.
What, you have reliable 5-minute transmission? No, that's right. It hasn't
Yeah, it's
transmitted
1:55 now,
Right,
so it
yeah,
just needs
it'll
to
transmit in another minute.
So it's collecting it.
Transmitting now.
It's collecting it to the
Maybe we could look at
chip, to the software. And then once it's finished collecting those readings, you get in there and scrub all you want because it has its data and then it transmits.
I mean, honestly, I usually just assume if I'm cleaning it quick enough that I'm just gonna. It seems
not
too
gonna
much
catch it.
effort.
Well, I'm a little slower moving than this, so when I get in there, I'm picking up sediment around it, and then I'll get this weird, like before and after
So
thing
it's a
going
good
on.
point about the situational kind of dynamics to these things where you have special, it's a different scenario at each spot really, and that's a good point about the sediment.
12:51.
Okay.
We're about an hour off.
Oh, that's EST though.
We don't get it.
And we're in EDT. That's a good point though. Okay, so everyone note that on the Dream Hosters, it's EST. We're in daylight, so it's an hour behind in terms of how it's listing the data, in terms of the timestamp. Okay, so all right, let's move on to just doing discharge type stuff. So.
Should we break into 2 groups?
Yeah,
Well,
so, and you want to do the tagline distances again?
Yeah, so let's, everyone get out their stream discharge
It's
sheets.
not a 5-minute delay from what it's reading on here, on the
It's the 5 minutes.
CSV, there might be a 5.
That is whatever the
You went for a jog.
Doesn't help when
Why don't you pull it
vibration
off
of
a little
whatever
bit?
the clock
I
is
see
set
why
at
this group
is
didn't
flow
get the
rate.
samples
I mean, but
processed in that
correlating
last
this my fault.
session.
Oh yeah,
What?
yeah.
It is.
But
What are you talking about?
It's just like,
clock inside of that
They're Karen.
that is collecting at exactly 5 minutes.
Right.
My delay between, because I know it's like, okay, it's at 5, it just collected it.
So
I
the
don't see
foot
that
on this
show
tool
up
here,
on the website as a change
that
for
foot
like 20
is
seconds.
part of the whole like
So there's delay between this going
elevation
to the
consistency, right? Like it's
cell
always
tower and
at
then
the same
over, but the
elevation.
depth collects at exactly 5-minute intervals.
Wait, the,
So
what
if
are
we
you
gotta
talking
like dive into all the
about? No,
details,
they
we
have to
will
move it
not
up
get
and down
discharged.
depending on the
Hold on.
sheet. You're talking like how,
All
where to
right,
measure.
everyone
like
get
when
your
they're measuring
stream
stream
discharge sheet out.
Foot.
Oh yeah, that's
Everyone
the
got
there.
that?
But you
Roy, you got your stream discharge sheet? Sorry to interrupt. Okay.
Yeah.
So, what we did to save time is we already laid out the measuring tape here. Everyone see that?
Yep.
That's the cross section, okay? That section of stream is where we're trying to do our measurement. The reason we chose that spot, look at the actual dimensions that we're looking at here. Look at the velocity of the flow. The ideal cross section for measuring discharge has a, symmetrical bed. This is ideal. This is not essential, but ideal. Has a symmetrical bed, an even bottom, and consistent flow. Is not on a bend in a stream, is on a straight stretch of stream. We have all those criteria here. So we stretch the tape from pin to pin. Okay, we have a rebar on this side, we have a rebar on that side. This is left bank looking down, that's right bank looking down. So in point 1 on your data sheet, in the first left-hand column, write LPIN, which is your left pin. The water depth there is going to be 0. Excuse me. The distance is going to be 0 because you're starting with the tape at 0. Okay. If you start with a tape that is broken, you just start whatever number you're at. Doesn't matter if you're starting at 0 or wherever. Okay. Our depth at that pin is going to be 0 as well. Then our next point, point 2, is going to be the left edge of water. Okay? So we're going to go straight from the pin to the left edge of water. The distance there is
2.55.
It's going to be
LEW here.
LEW.
And then distance along there is what Reagan's going to...
2.55 is left edge of water.
Okay. Okay, and then we're going to go down to point 3. We don't need to write anything in the first column. And in the second column, we're going to write the distance, which is
3.87.
3.87. The way we've set this up is just at 0, at 25% of the wetted width, at 50% of the wetted width, at 75%, and then at 100 on the other edge of water.
All right.
But if we
Is
were
that the
out,
Stroud method as opposed to the USGS?
No,
Okay.
it's a good question though. Stroud method is pretty much the same as EPA or something, which is at least 15
Okay.
we're reducing it for time. This method though, Yake and Wagner, the WUT team, they use that method for all of it because they feel like it's good enough for their work, for what they're trying to do.
Okay.
And if you have a well-chosen stream bed,
Okay.
then it really is pretty okay. The more the more variable the flow, the more variable the bottom, the more you're going to want to break it up.
Okay.
So we're kind of demonstrating the process here. And when Stroud came out to originally install this equipment, along this cross section did a very thorough, not just like cross section for discharge, but all the way up to where the pin is.
So when we put this in, we map the whole channel. So we're mapping on the stream bank so that we basically have below that tape, which is not, we would put a line level, and we would basically map that whole cross section up to a certain point on the rebar. So that then you just have a picture of this shape, and then you can predict the wetted area.
So you have the cross section topo for this, like the cross section of it,
Correct.
and you have topographical information.
Correct.
Yeah. Cool.
So are you guys ready for the next point?
50%. So the next at point 4, distance is.
5.19.
And the next one at 75%,
6.51.
6.51. And final,
Right edge of water.
yes,
Not yet.
correct.
So the right edge of water is 7.86.
Okay. And then final right pin,
Right pin is 12.68.
12.68.
The one I missed, guys, if anyone, I crowdsourced 7.86. Is that? Yeah. Okay.
Right edge of water.
Yeah.
So, if we laid those out just for efficiency in terms of this short time frame, if you were just doing this fresh, you know, you would just go across and try to put your measurements at any points where you see the contours really changing and or velocity changing, just trying to get representative sections of this across the reach. So, I demonstrated this to you, Roy, already, but we're gonna use this flow meter. So, Carol,
Got this one on.
we have this, so yeah, you can take that off, or if you want to, you can keep it on for now. So this is the sensor, okay? It's attaches to here. You clamp it down. It doesn't really matter whether it's like this or this. And then tighten that up. It measures electromagnetically.
And is this the Marsh McBurney? Or
This is a Marsh McBurney.
Okay, all right.
This is a Marsh McBurney. They don't make this model anymore. I like it a lot because it's just simple. You can't calculate actual discharge with this. You just get flow. Some of these other models, newer models, you can actually put in depth and distance and it'll calculate discharge on the spot. This is sort of a training, and it's kind of, if you have this type of thing and you have the calculator like we do, it doesn't matter one way or the other. But so this is the unit. Basically all that you do with this is turn it on and it's going to start reading. It goes through and takes readings for about 30 seconds and then it'll give you an average. That's what you'll record on your sheet. As I pointed out in the diagram this morning, you want to position this thing so that you're measuring velocity at a little over halfway down, 60% down from the top of the water. The way you do that is to put this on the stream bottom. So I'll position myself this way. If my water level was here at 0.5, I'm going to come up here to this, and it's a little backwards, but you go and I just happen to be right there, 0.50. If it was 0.52, if the depth here, if the water depth was here at 0.52, these are in 2 centimeter increments. If it depth here was at 0.52, and you
So
just
you
bring
just
this
put
up.
that to depth and it automatically puts it at 60%.
Yep, so you don't have to do any
calculate.
calculation.
Okay.
Now, Michael Griffith was out here with his cheaper meter. He doesn't have anything like that on it, so he just does a coarse sort of estimate and actually holds it on his shoe, you know, to hold it steady at that certain depth.
All right.
So then, when you say the water depth, so the water itself is at 5.2. Are you putting 5.2 here?
0.52.
0.52.
Yeah, because it's in meters, so it would be 0.52. Exactly.
All right, 0.52.
Exactly.
Okay.
So, what we want to do now is have, how many pairs do we have here? 1, 2, 3. Okay. Okay, so let's have, who's gonna be, I guess I'll just demo. So why don't we have 2 pairs come down here with me, and the rest of the folks go with Reagan. Darren can stay with Reagan so you can continue your conversation. And
Very quiet.
who's your partner?
Darren.
Darren's your partner.
Yep.
I'm
Okay.
sorry. I work with him all the time, so I
And your partner is Roy,
Roy.
and you 2 are partners. Okay. And Carol, okay, why don't you 2 come with me? Carol and you come with me.
Am I taking the bottle
And
with me?
Can we go with you, or
Yeah, I think so.
huh?
can we go with you, or
Yeah, you can go with me.
I'm like, really?
You're taking a sample, right?
Actually, why don't, huh?
She asked if she needed the bottle.
No, you don't need it right now. We're gonna switch up, but I just don't. Reagan can do some.
Yeah.
So when I call.
All right.
Who's
Whoever
very
wants to
important.
do grab samples first, go with Reagan.
Okay, cool. And if anyone else wants to do a grab sample demo, I can take another pair.
Yeah, it's super slick. So
Roy.
Yes.
Grab this other stick that's there.
Yeah. Good maneuvering. Way to avoid the trip
Well done.
wire.
Yeah.
I like
Avoid
what
the
I
trip
see.
wires. Sue, I have a feeling you're gonna get wet.
Did you know that about the 0.6?
Why do you think I tossed
I
my
didn't know it was
phone?
an automatic adjustment.
I didn't know either.
Nice to know. It'll make life easier.
Yeah. So I was like,
I was just planning to do it the Michael Griffith way. Just, well, just
get-
whatever.
just look at it,
Just
like-
kind of. Well, on ours, I knew you could adjust it.
yeah.
So
So
you
I
don't
didn't
need
know,
the
I
feet.
didn't realize that was like exactly 0.6.
Yeah.
Unless
Oh, that was an expert hop. Thank you. Yay.
Yeah. So that's why I think we were asking that too, though. Like, why are there weird increments up here?
So can you put this in with a mini sledge or a full-size sledgehammer?
Yeah, a mini sled.
Most of the
Are
time.
you two joining me for grab demoing?
But you have
We
to
might
use
as well
a,
since they're all
you
down.
have to use a
Do that
block.
first.
So you don't
I just don't wanna
land
miss
at the
that
top.
again.
You have to
yeah, I want to see
climb.
that
You can't
just
do
to
that
double check with that.
Put a
You see that
brick or a
sit
piece of wood. Okay.
clean
Or
that
you're,
thing over it all. and you'll
it'll
never get it.
smash it.
That is
Everyone's gonna do
amazingly
everything.
tight.
Okay.
Just switch places.
Like that's silk tight. I had to last summer we had a crazy blast of water come through
hand me that?
and a very small
I got
grain
it.
got shoved between
Do you guys have your
pressure
container?
transducer membrane, which
Oh, I
meant-
forgot. We're going. We were.
Hold up.
So I was thinking, like, wait a minute, it's
Actually, could
going
work.
up and then it's going down.
Pull the
pin, pull it out, clean it.
Science?
With-
Oh, yeah.
I had to get
Yeah,
a
yeah.
can,
Yeah, that was great.
Never seen you.
piece of
Oh, good.
sand,
Thanks.
And then I slid it back.
Yeah, we'll do a new version of that this
I'd
year.
love- yeah.
Yeah, definitely.
Cool, yeah. So come up here a little bit if you need. You guys probably were not aware of this today because you've already done the CSS stuff. But in theory, you would have done this part first.
Yeah,
Just letting you know.
Yeah, all right.
How many of you guys have taken grab samples already before?
We have.
Oh, you're all pros. Okay, cool. So can I take yours? First thing I'm going to do is demonstrate everything you shouldn't do. And I'm going to have you guys tell me what I did wrong. Okay, since you're experienced enough where you should be able to identify it. Okay, we ready? Clean that up. Yeah.
Yeah, you should be facing the other way. And you're
You want a summary at the end, or?
Done. All right. What was wrong about that, apart from everything?
you should be taking it upstream so you're not capturing the sediment you're picking up.
Yeah, and if, even if you're standing still, you're going to be kicking stuff up. You don't want to taint the sample that
Probably
way.
shouldn't spit in your bottle.
Yeah, don't do any of what I did at the beginning. It does not need to be blown on. You do not need to put your fingers in it. Stroud,
It should be clean when it goes like a
that's the thing. I think Stroud sends them pre-sterilized. If not, and you guys will be working with Nalgene's. We often, because we work with the Academy as well, and their preference is for cube painters. They're like pliable plastic cubes that you can pop out.
They're cool.
They're really cool, but they come folded in. And so you have to pop them out, and people are tempted to put their fingers in to help. So it's not gonna, you're not gonna be too tempted with an Nalgene, but in case we ever switch to that equipment, I want to let you know, it's sterile in there. Do not mess it up by popping out, putting your fingers in. Okay, great. So
Sloshing around.
Yeah, you don't need to,
Stir up the bottom.
yeah, that
or
was
you can just
completely unnecessary.
gently stick
And
under
you
the...
uncap once you're in the water.
Ooh, that's a new one. I don't typically
Yeah, you
do
don't
that.
uncap up here because then you're going to start capturing surface stuff.
Oh,
You
I see
uncap
what
when
you
you're
mean.
in the water column.
Yeah.
Yeah, that's for shallow. Otherwise, you can just go straight down.
That's what we've been describing.
Straight down.
But it's a good thing for
But for
shallow.
shallow, yeah, we haven't been doing that. So, also, I really rubbed this guy against the bottom.
Okay.
I was really getting in there. We've been talking about now, and it's challenging. And Darren, feel free to riff off this if I'm not getting this quite right. Ideally, you're getting in at 60%, right? You're going into the column, and then You're going straight down, and then once you're there, flipping up, so you're sampling the full water column. We are in it's too shallow to really do that. So what we're trying to do is, we don't want to be sampling right at the stony bottom layer, and we don't want to be getting right at the top. So in a shallow stream like this, you can't follow the perfect method. You're just still trying to get as much of the water column as you can without getting the bottom or getting the very top. Does that make sense?
Yeah. So if you take that and you leave the cap on and you put it down and you uncap it, then you can collect that sample.
Yeah, cool.
Really
Awesome.
easy.
Perfect. Another thing, did you notice anything about my rinsing technique?
Yeah, it didn't really rinse it. You fill the whole thing.
Yeah. Triple rinsing, yep, and same idea. You're gonna, put the lid back on. Really, you're conditioning the entire container. And then you're pouring behind you. So when you collect the sample, you're facing upstream. When you're rinsing, you're facing upstream. You don't be pouring what you just sloshed around here right in front of you, always behind. So the correct process is triple rinse, pour behind. When you're ready to take the sample, lid on,
Yeah, you do it that way, yeah.
submerging, taking it off, and then again collecting as much of the water column as you can without getting the very bottom.
Or the very bottom.
Yeah. So that's all about collection. Make sense?
Mm-hmm.
Okay, cool. So you're also going to be labeling. It's a blank label. What do you guys think would be good information to have on this label?
Date.
Date is really important. Yeah.
Time, date,
Time.
location.
So like noon, like noonish. Is that a good time?
No, like to the minute.
To the minute time, yeah. So what I'd like to see you guys do when we come out and do a sampling, we're typically with one other person. So once you're done triple rinsing, say to your recorder, I'm going to be collecting now, and then they can get the exact time. Because typically the two are pretty quick. You might get them the same minute. Just last time as we did it, it did change. We did have like a different minute. It'll relate still to the same data point, but you want to be as accurate as possible.
And you want to try and hit. Yeah, you still have a 5-minute measurement in there, but it still is.
It's important.
You need to be tied to when that is measuring the turbidity.
So just be sure, communicate with your reporter, or if you're by yourself noting, it's not just when you're triple rinsing, it's when you're collecting the actual sample, and just make that communication. So to the minute. What else we've got date and time.
Location, the site, ID or
Yes,
whatever.
site ID. We've been having some people put the creek itself. Like, it's good. It's not a bad idea. The site ID is more important, and then it'll tell you what creek you're on. But if you have room, not a bad idea to have them. And finally, your initials and your last name. Sorry, who collected. A lot of this is going to be related to the data sheet you have. So if you get into a pickle, you can check that. The data sheet, it's located on the front of the field visit sheet in the middle, partway down. And it'll ask you also what lab you're sending it to, things like that. Since we're analyzing on site today, we don't have to always fill that in, but if you're sending them to Stroud, like there's some other fields in there that don't go on this label that are there. But there's things like how much of a sample. This is 1 liter, easy stuff. All good? Okay, so if we're clear on that, I'll have you guys take turns collecting your sample. I think I stole yours, so I'll give this one back to you. And so I forget one last thing. I've chosen this point strategically. A couple things. It is the deepest point I think we can get to and effectively take our sample. Again, it's a shallower stream. That might not always be a factor, but here, making sure we can take the sample is key without getting too close to the bank. When you get to the bank, it's kind of its own like microenvironment. You're gonna have different kind of sediment, leaf stuff. So you want to pick a spot that, one, you can actually do your sampling in, and two, is characteristic of your stream. So that's why I've kind of selected this part. It's kind of in the primary channel of the stream anyways. So I think we're good to go. Whoever wants to come into the spot, I'll watch over.
I get started.
I'll let you go.
I can hold.
All right. And you want me to go through the triple rinsing?
Yeah, I want to do the triple rinsing. I know that one's already been kind of, it's gone through the ringer already, but for the sake of practice. think I sprinkled it around.
I don't know. You could have gotten it all over us a little bit.
All right, sample time, whatever it is.
It is 217.
All right.
You're gonna want to get that also as full as possible. Yeah.
Yeah, I
because
came up to the top.
You need the
You
full-
need to tap it in the water.
And then what you can do is if you don't like the sample, you just dump it out.
Yeah.
Give it a rinse and do it again. That's the nice thing.
about water.
Yeah.
And did you,
Soil, you really don't
did
have
you
that.
guys use the full 1 liter when you were doing your TSS today?
Yeah.
Yes.
This is 1 liter, so you're really gonna want to fill it because
Oh yeah, right to the
there's
very
not
top.
much
Yeah.
wiggle room.
No.
This is a heads up there.
All right.
Well done. Okay. Yeah, I guess I don't really need to keep How was this morning? It's fun. Yeah. It's cool to see everything come together. Was that 3?
That was 3.
Okay.
Cap
so-
it. Oh, yeah.
Shallow. I'm gonna scoop up
You were
rocks.
ready though. Okay.
I was gonna do it, but I'm gonna scoop up rocks. I just know it.
I've got a time of 2:18. Nice.
Did you need to cap it? I guess once it's full, it doesn't matter, right? When you bring it up to the surface, or should you still cap
underwater?
it? Yeah, because they were gonna cap it underwater.
Yeah, they capped it underwater to avoid getting too much on the surface.
Even though it's like full, or I guess you think, all right, we got it.
I mean, yeah, it was full when I brought it up. So, good practice. Just gotta change it.
All right. Excellent. So that's Brad's sample. Do you have any lingering questions before you go back and practice discharge?
I don't think so.
Thank you.
Thank you.
Yeah, of course. Yeah. I don't think you need to keep that water. You can probably pour that out.
Yeah, I was going to say, do we need to keep our sample?
I
Okay.
mean, we debated from the morning because
I didn't know if they were going to test
thought this
it
was
back
our
there.
trophy.
You can drink
Your
it.
trophy is
I'll
our
just
Ridley
set
Creek
it
water.
up, This was
I'll
our
take that
souvenir.
back and watch my trib like freak out. Great water.
Manna from heaven.
Yeah.
Restorative.
Yeah.
There's so many cats.
We're down at the bottom. I'm going to.
Water depth is.
So the next number is 60.
You want to sort of look at, you don't want to read the build-up, so you want to use probably, I think a good number would just be 0.3.
Yeah, we can read that. I didn't see
0.3.
the number on it. 0.3.
Ooh, look.
Yeah, so you're getting something.
What is
so,
it?
So if we move this up to 0.3 right there,
Now we're at 60.
and we'll just let that go. So, I mean, I guess just say 0 though. That's what we were getting. That's part of why we're doing this, just to see variability.
But would you note a condition that was obstructing a proper reading?
Yeah, and you could note that in the comments. So you
Right.
could say there, like
So
roots
veggie root,
obstructed.
yeah.
So what's your
0.29, and then it
0.55.
popped up. Yeah.
What is it?
After
0.55.
two cycles.
I've been starting it off clean.
And the
was it?
depth was
Turning it back on, so
0.3.
it lose like 15 minutes to do it. Because I thought that
Yeah.
like cleaning it because the service too much.
Well, it would make spicy after,
Okay, so let's
could
move
make
to,
fires after the
move to
I've never
center
turned it
now.
off. I just have gone in and
Alright, I
know
know
to
there's
get
a whole
what you know at the time, but
Yeah.
it doesn't. It's not that big of a
What's the
deal.
next number, Sue?
Now I got change
It
it.
is 5.19.
So I'm just thinking like, because it's not fast moving to do it.
Right there.
It takes like
Here, you want to do it? And
longer
I'll
before
record.
it to disperse. That's why.
Yeah.
Oh my God, I ran out of hands.
So go down there and read the depth.
Next would be what would that be? 2 point. Because that's 2, right?
Well, or yeah, from 0.2 meters.
No, it's 0.2 meters.
0.2 meters.
And then
And that's 0.22.
0.22.
So you want to say point.
Point
It's
two,
really
point-
kind of. If you look at the backside, it's really about just 0.2, isn't it?
Yeah.
So then you bring this.
And put it to.
So take that.
Okay.
And then bring this up with your other hand and bring that up to 0.20. Yep.
Okay. And
Okay.
then
And then
push
just
the
leave it
button.
read.
Or you don't have to push the button again?
No, it just keeps reading.
Does it actually starts a new count and it realizes that something was interrupted, right?
Yeah, and if you're adjusting it in the middle of something, you don't want to take that final line. And if we were being really precise here, we might have even let that previous one run through again, just to be sure. So
And this guy filming, out of the shot. You get out of the
oh
TV.
yeah,
Oh, my bad.
He is in the flow.
Well, let's see, what is it with and without, and it's footing away.
And now it's all messed up.
Yeah, it is.
All right, so what did it give you?
0.61.
So let's run. Okay, so let's use that as an example. Let it run through one more time.
Do you like put it on the left side and just go, I got one? Or
No,
do you just...
I would just let it run through until you get a consistent value.
Okay.
Yeah, that sounds really
So what is the, like, if you're looking at a stream, you're going to know, like, instantly. If you get one reading here, and you look and you see, like, a shallower condition or what have you, I bet you that your brain is like, oh, well, I know velocity is actually shifting. This is the strong, this is the strongest current. That's the weakest. Like, you're probably, like, so attuned. But, like, what is the presumption as you move across the stream bed? Like, are you going to see the edges be weaker velocity flow measurement?
I mean, that's standard, but it's real varied because if you're on a turn.
Yeah. So do you want to read those different locations as well? Like, I guess I see that this is existing, like a measurement
Might just be like a foot in.
but
Well, I think he tries to just get above top of bank.
and then getting field data
Like, I think
away
that's,
from
see how
it,
it evens out
using your
that
float
we used to
method
put in?
and like
So he
checking out
might
like a section where
Could
you're
have
like,
went a little
think something's
No, I mean,
happening
you get
here,
one
like,
closer in.
there's erosion or
Because the bank also
Well,
goes,
there's lots of
flats
ways you
out,
can
flattens
look at
out,
that. I mean,
so-
this is
so it
just
might
to
be
get
like
the
a
amount
foot
of
or 2
flow.
minutes.
So you just sort of
Yeah, the idea being you want to
Just
know
do
when
it where you
your
can measure.
velocity or when your discharge is no good anymore, and that's when it crests.
0.44.
Yeah, that's when it's just
It's a lot less.
It goes above top of bank.
I wonder if we've actually come down in flow since this morning.
Jacob's Creek is kind of crazy because
Yes.
Yes.
So you guys go with
We need to know
Reagan.
right edge of water. We need to know how to deal with this edge
It's
of water.
0 and 0 because if it's a gradual, like this, it's right there. It's going to be right there. Now,
So that would be zero.
0 and 0. It's
0.47.
if you have a drop off, if it's not gradual. That's how we've been doing it. There's not, I mean,
That's what when we got
What's the next
when we went through our
0.47.
research training from the academy. They were of the same opinion. That the edge of
What is
water
it?
should be 0, 0.
Oh, sorry.
It's like
6.51.
And then when we do it,
So you guys
we
continue
do our
with
edge
that.
of water and we try to find our next measurement is close to the that we can take the next.
I think it's after the 6 meters.
We marked
So 6.51. Way over there by the shoulder.
because it drops off. See, it drops off right there. That's valid, yeah.
There's no bank. This is straight.
Yeah, this one's little incised at that point.
Yeah, it looks like that, right?
So I thought you were. I saw like a swapper
even
that you
for
were
one-
about to
yeah.
use, or you don't.
Yeah, we only needed 2 before, so we just decided to just go with these 2.
How you like the swapper?
I mean, it seems fine.
Okay.
Reagan thinks it's a little more just kind of, whatever, not as easy to use, but
Because that.
they're a lot cheaper.
Yeah, I was.
And you can get discharge straight from it.
Yeah.
You can add the.
Now you say it like this. Flow, mate.
Yeah, because we were looking at the swapper, and I called the swapper person, and then they said it's not really good for stream velocity that are lower than a certain point. So we went with the pygmy, where USGS said was probably the best for the bang a buck. Where you're getting, you're not paying that much money for the electronic version. It's mechanical, but
Pygmy's the one that goes this way.
no, it's a smaller spinner. It's like the swapper.
Oh, okay.
It's a smaller.
Who makes it?
Um,
Is it Lawton?
No.
no. I have it in the car. I can show it to you. Because
It
there's
wasn't meter, right?
no, there's like the AA that you use for
Yeah.
bigger,
Look it up, right?
higher velocity, and then there's the pygmy.
How are we doing on time?
2:26.
What time do we need to leave here?
3.
Probably by.
We need to
If
leave
we need to be
here.
back by 3. We probably need to leave here like 10 to 3. Right?
No, I think we leave here by 3. It takes 10 minutes to get there, 5 minutes to get back, so
Yeah.
we get there at
Yeah, that's
3:15.
probably
We're
right.
supposed to be back there at 3:15.
Yeah, so we have to leave here at 3.
We just have to leave here at latest 3.
Yeah.
All right, so we've got a half hour.
Pygmy? Is that what it was in front?
It's a PY, right?
All right.
Yeah.
So
Meter. Do like
No, but like you get 3 readings, and one of them's bumps, one of them's 0.68, and one of them's 0.72. Would you just cut the difference?
all right. How are you guys doing here?
Pretty good.
You got everything?
What do you do in a condition where that?
Where's your measurement?
7.86.
7.86. Yeah, so that's just gonna be 0.
Okay, so even if you were right here, let's just say that you fudged your 25%.
Swapper doesn't need pygmy?
no, Swapper's his own brand. That's his own. Swapper.
All I
yeah.
could find are people like selling it. Where's the pygmy go? It's on there.
Okay, it's fine.
You can measure what it is in place. Is that the brand?
No. No, I think it's quite.
I didn't find their site, which just gives me a whole bunch of fake.
So let's
That's the
switch,
pygmy.
but guys, let's switch. But I forgot to mention we want to say at the beginning and end staff gauge height and sensor depth at the beginning and
That's
end.
what we've been discussing.
So let's look right now at what sensor depth is and put it on our form. Carol?
Yeah.
Okay, all right, get the staff gauge. So, sensor depth, right now is 203. Okay, so this would be at your end. You're just finishing. And then for you guys,
That's the start.
that's going to be your start, okay? And then,
For sensor depth.
when you guys started, you just go to start time and end time. So,
No, I didn't. No, we didn't.
okay, so let's do start time and end time. Sorry, that's
205.
my bad. I'm too instructed. So, how long is that? 15 minutes? Yeah.
We know right now.
What was your staff gauge, Carol?
It was 0.2825 end time. Oh, yeah, we didn't.
Would you like me to
If you
order it
look
for you?
online, it is fluctuating a little. So at the beginning, I would guess
Staff gauge
based
height.
on what
When
I'm
you roll down here, you're going to be like, staff gauge height, mark it. And you're going to get in the water, you're going to position yourself, and you're going to be like, all right, let's start doing this. Hit it. Like, just, I mean, it's systematic, right?
Yeah, so you might
Sorry,
as
I'm
well
like
still
all over the
do.
place, but yeah. And then
No,
you leave,
so
hit the
Carol-
staff gauge height again.
Carol,
Yeah.
what was staff gauge height?
when I at the end,
just
at the
now.
end was 2.2825.
0.28, 0.285. Okay, great.
That's
So,
what.
Does it look like this?
I don't know what that means.
The end point was
50 millimeters.
0.285. 2.8 and quarter, which rounds up to 2.5.
How detailed
it's
do you
only
need?
half centimeter increments.
Okay, so 0.282.
Okay. Table, so no,
No, it's still
no. That would be half centimeter when it ends in a 0 or
Then it would have
5.
to be 0.28. Okay.
0.285. All right, so then all right, so Carol and Maddie, at the start it was
Yeah, because it's 3.
wait,
Like 1,000 millimeter per meter.
May I suggest that when we go back to the RCC, we can bring it up on
Yeah.
like the big screen. And it's a lot easier to navigate through past data.
All right,
at that
so
point. So you measured.
make sure to write down your start and end time when you're doing these flow measurements.
But when did you, but Darren measured it? Just before we got into the stream?
Just when we just finished doing our.
Does someone have a
We measured it when we were
ruler so we can get to see the offsets correct?
Oh, yours? Yours is probably 5 minutes before
We
that.
have time. We're still working here though. So, all right, so you guys go with Reagan. You guys stay these things here. There we go. And then
Thank you.
all right, so Jerry, why don't you just start us off?
All right. Grab the
I got it.
good catch.
Thank
I don't want to
you.
lose this.
Yep.
Yeah, so for the sake
It's a
of
fast stream.
so long as you understand the
Yeah, mine actually.
Mine's like, yeah.
Back later.
we missed the data point at the beginning of that.
Darren, you don't want to stand right in front of the... We all forgot that last time.
I should have this backwards. Alright, how do you start this? Record?
Want to take this one?
Oh, here it is, 0.38.
Yeah, so you can push your heel in. And just work your way in. That's soft, hydrated.
The bar finishes it. That's the first, so this next line is the first.
Yeah. So if you guys want, you can start over there.
All right.
Start at that edge, and that'll be 0, 0 over there. You know.
What number is supposed to be at? 8 meters?
It was 7.86 is right edge of
Yeah.
right edge of water.
So, you know, really, if it's this type of thing, it's just going to be a 0 depth and a 0 velocity. So then you just come out here to this one. What's that one, Steve?
That one is 651.
Yeah. 6.51.
0.05.
Yep.
I got the 0.05.
Meters. 1.
This is 1.
I think it's got to go until it takes a reading, right? Oh, what'd you get?
Oh, meters, yeah.
I got
What'd you get for depth?
0.1. Yeah.
1 meter per second.
I'm taking any pictures.
No, the depth. The water
The
depth.
next distance.
Do we have to press a button in order for this to go? Or
It's
let
just
it-
going. So you can take it, or you can,
There it is. Okay, so
like
it's
after it does the counting down thing.
0.43.
I remember this morning what we got to this afternoon.
And this, I think this is the area it was changing a lot. So like we got, I think 0.7, 0.6, and you guys just got like 0.4.
0.43, yeah.
So it's
So,
variable.
so this is 0.1, then this is 0.102.
0.12,
Oh, 0.12.
0.14,
Okay.
6, 1.8, and then 0.2.
Okay.
So you
Yeah.
had 1.1 for the depth there?
No, I just had 0.1.
1,
Yeah. Okay.
0.1, and
Yeah.
then that was
Yeah, I had that
set.
at point.
Yeah.
Yeah, because then one.
Let me see where you set that.
0.10.
Here, let's show what that. So this is. It was here. Is it in the camera?
Yeah.
Okay, so that's 0.1.
That's 0.1. You set it to 0.10 there.
1 point. Yep. And then 1.2 is the next one if we go.
Oh. Yeah, okay.
Is it focused?
Yeah.
All right, we good?
So the next one was 5.19.
Or, you know, or I guess 0.28 or 0.9 or 0.3, somewhere in there.
Other side's feet. There you go. 5 meters.
5.1.
Oh, sorry.
0.19. So 0.1 down there.
Oh, that, okay. And you point
So 5.1.
Oh, here's 5.
there, okay.
Oh wait, so I have 5.1.
5 meters. 0.19.
Wait till
All right.
So this is reading. So that's
1.28. 0.18. Sorry, 0.18.
0.18.
Just bouncing all over the place. Huh?
No, it's going through a 30-second.
0.24.
and then it gives you the average. So 0.55.
Gotcha. 0.55.
0.24.
0.24. Yeah, 0.24.
And one of the things that I found with these, I don't know if they talked about
So
it,
should
that
we-
bulb,
Yeah.
you have to make sure that the center of that thing is
Let's double check with
straight
this.
into
Right.
Just captured that.
Did she fall?
No, she's just taking a
Just hanging
rest.
out. It's really cooling if you're hot.
5.19.
Yeah, definitely.
You guys
So
think we're at the same point.
That's what stinks about the shallow
Combine your
streams, right?
measurements.
Yeah.
Sure, combine your measurements.
Okay. You guys.
Or,
No, five-
or just whatever.
Here, 5.19 right there.
Yeah, we're good. You want to swap?
Right there. Sure. We're looking at feet.
Okay. Yeah. All right.
So,
Go ahead.
You want to do it?
Yeah,
I just hit it.
Okay.
Okay, good.
Or that, right?
I want to get us to the orange float.
Yeah, yeah.
What's the next one?
Go ahead. We can do this quick. 3.87. 3.87. Yeah, we're gonna, yeah, we could just swap. Yeah.
Oh, okay.
Nick, never mind. We'll just swap the measurements.
Okay.
Oh, you guys got 4, we got 2.
We're faster.
Yeah.
4.18. Nick, take the camera from me. Will
Here
you?
going up.
Sorry.
Sorry.
Yeah. We're.
Midpoint.
Or do you want us to each collect our own set, or
Wait,
just share the data?
What are you recording right now? Velocity?
No, we're swapping both. I thought you told us to combine them.
Well, I thought that was when you were overlapping. Don't just combine
Oh, okay.
because
Okay.
we
All right,
want to like
so
see how the
Erase mine, don't put that
You want to see
on.
who's the worst?
Okay,
not worse. We just want to see.
How repeatable.
All right, yeah. Replication. I got it.
What's the number, Steve?
So 5.19 was the next.
6.51.
3.87.
3.87.
5.19. This is 6.51.
All right.
Okay, so
Here, you wanna do the last two so that
Oh, yeah,
you can,
good
you can
idea.
get it? Yeah. So you need to hold this first so we don't drop it. Just hold. We'll switch off hands. Just hold. Just touch this. Oh. All right, ready?
So you gotta come closer to me then.
Oh wait, shit, my bad.
You can wear it. We're just gonna have to hug.
Wait, can you get my glove? Oops.
So it was 3.87, right? 389. No,
And the
389,
entire,
right? Oh no, it was 387. Right
387.
387.
Okay, so you can just
So that's like there, which would be 2.8. Or
That
no,
was 3, but do you see 0.2? What do you?
or 0.28. No.
your angle
Would
too.
you call? Oh yeah. Would you call that?
So that's 0.2. So I'd probably I think 0.18 would be a good estimate of that.
Is that a point?
That's 0.3, so it'd be
Oh,
0.28.
that's 0.3.
Right?
Sorry.
No, that's
Yeah,
okay.
0.28.
Okay.
Or, you know, that's really piling up, and it's varying. I don't know, 0.28, 0.29 probably.
So you do, okay.
Yeah, let's go in between.
0.29.
We'll call it 0.29.
So do you do it from the front or I guess from the
Back.
back? From the back? Okay.
But the
So-
kind of sinks in the back too. So I think it's.
Do you usually round off here, or will you go right in the middle of two lines? Doesn't matter. Doesn't really matter. Right?
try to be as precise as possible. But I don't think it's going to really make a whole lot of difference. Yeah, there you go. And that, you just got to make sure that that thing is really like right on with current.
When you say on the current, like right straight on.
Yes.
Yeah.
Yes. And if you move that thing at all, you know, you kind of this. You definitely want, if you've been moving the meter while this is going on, you want to let it go one time through and just let it be totally still.
Can you move your hand for a second? Just up. Your other hand.
Let it go through one more time.
Yep. So you had a 0.29? All right.
Mm-hmm. .59.
All right.
Next one is
Next
what?
one is
Right edge of water.
0.1. No, 0.255. What?
That can't be right.
Basically, right edge of water.
Or is it 2.55?
2.5. Yeah.
Did I put 2.25?
Yeah.
Yeah. I was struggling with my gear when they were shouting out the numbers, so I copied off somebody. 2.5.
2.55.
Which is right here. Oh, jeez.
What the?
That's like muddy. I'm going here.
So edge of water, we're still measuring it.
Yeah, I'm calling the edge of water 2.6 to be honest.
2.6?
Yeah.
So that's 0.3, that's 0.2, 0.22.
0.22?
Yep.
You look at the back, right?
Yep.
Head on?
Yep.
Okay.
0.2, or no, that's 0.12? No, that's 0.2. That's 0.2, right?
0.22 is the next one.
That's 0.22. So that's
0.24, yes.
So it's 0.22.
We'll let it go one more time. We're good.
Yeah, we should definitely mark ours.
0.1.
Can you lift it up higher? Or actually,
Lift this up?
yeah. I want to release. So the point, if you drop this, drop it down all the way. I just want to see how you go. Okay, so the first half is 1.
What's the depth it can go?
So that's 864.
So we go to about 0.4.
Yeah.
Oh, I'm on the wire.
Oh. So 246. Oh wait, 864.
We are done. We're done. We're just messing around a little bit. Oh, 245. So what did we say?
864. It goes up to
4.
But then,
so a little less.
yeah, this can go low, but there's no nothing in the back.
Yeah. Yeah, but doesn't that sit?
It sits lower. Yeah, I mean,
Not the same, right? Okay. Good.
Go online to get the sensor back.
Oh wait, did we get the depth? Sorry.
Yeah.
What was the?
Hopefully it didn't reload the 127, right?
I got it. 193.7.
Oh, he just said it. 193 points. Thank you.
And then staff gauge
Wow,
is
gone down a lot.
Jerry, you want to come read the staff gauge?
Sure. And so to the nearest 0.5.
Yeah, I mean, it's
What tree is this?
so, we're at
Yeah, 30, so...
30, that's 27.5 right there.
Oh, okay, that's
28, so probably
Oh, wait, each is
half a centimeter.
35, 36, 37, each is a centimeter, isn't it? There's only 5 lines between 35 and 40.
What's the issue we were having? Was it contact or something?
36, 37.
No, it was me. It was.
Oh, we were touching.
Oh,
To do that here?
No, because there's no. It doesn't rely off of this.
Oh, right.
'Cause
Right, it's all
it-
contained in the
Yeah.
pressure transfer.
Oh.
Probably should have just thrown right for a pressure transfer.
No, it's. I mean, it's just. So we could get an upgrade where it attaches directly like this,
Yeah.
instead of relying off of this. This is really, if you're going to like murky waters.
0.285.
All right, 0.285
285.
staff gauge.
Same thing.
Okay, good.
So that's weird. Look, this one went 10.
I think somebody must have read it wrong.
Wait, let me hold that. Oh, we got it.
Attached to it. I got it. Thank you.
So you saw as you started to angle it, the air level looks like
Oh.